Welcome. The question before us says, earth is required to be excavated from borrow pits for building an embankment. The wet unit weight of undisturbed soil is 18 kilonewtons per meter cube and its water content is 8%. In order to build a 4-meter high embankment with top 2 meters and side slopes of 1:1, estimate the quantity of earth required to be excavated per meter length of embankment. The dry unit weight required in the embankment is 15 kilonewtons per meter cube with moisture content of 10%. Assume the specific gravity of solids as 2.67. Also, determine the void ratio and degree of saturation of the soil in both the undisturbed and remolded state. Okay, so let's start by saying solution. So we've been given the the dimensions for this embankment. Let's visualize what it's going to look like. Say a top width of 2 meters, and then says it has a side slope of 1:1. 1:1. Interesting. So let's say this is the side slope 1:1. Also at this point 1:1. So it has a height of 4 meters. So we're having 1:1. It means that if I cut through this place, if this is 4, that means this is also 4. This is also 4. And this is 2 meters, which gives us this total length to be 10 meters, right? Gives us that total length to be 10 meters. So the dry unit weight of soil in borrow pit, as the undisturbed soil, right, is given by this relationship d all over 1 plus, which is equals to 18 over 1.08, that is equals to 16.7 kilonewton per meter cube. The volume of embankment per meter length let us denote it by VE. So the volume of embankment per meter length is equals to the area of the trapezium multiplied by 1 meter, right, which is equals to 24 meter cube. So you know the area of a trapezium A equals to A plus B over 2 times H. I hope you can look it up easily. And look it up. So the value of the volume of earth required to be excavated per meter length, let's denote it as VEX. VX equals to the volume of embankment per meter times the dry unit weight of the embankment all over the dry unit weight of the borrow pit is equals to 21 meter cube. So we're also asked to find the degree of saturation in undisturbed and remolded state. So let's start with the undisturbed state. So SR will be given by this relationship all over E. That's our void ratio. But our void ratio is also given by this relationship D minus 1. Therefore, our void ratio becomes 2.67 times 9.81 all over 16.7 minus 1, which is equals to 0.568. You can say 0.57. Therefore, our void ratio SR, rather our degree of saturation SR becomes 8 times 2.67 all over 0.568. It gives us 37%. So when we also look at it from the remolded state, degree of saturation SR is still given by the same relationship, and E is also still given by the same relationship, and so E as a void ratio becomes 2.67 times 9.81 all over the dry density of the embankment minus 1 equals to 0.75. And so our degree of saturation was to moisture content of the embankment multiplied by specific gravity all over 0.75, which is equals to 36%. See that there is no much difference between them. So with that, we've come to the end. The PowerPoint um, document is attached to the video in the description. Okay, so thank you. Like, share, and subscribe. Have a wonderful time learning.